Hi friends, here we are given f of x equal to sin x plus cos x and g of x equal to x square minus 1. Then g of f of x, this should be invertible. What does that mean? If a function can have an inverse only when it is 1 1. Right. When is it 1 1? When it is either continuously increasing or continuously decreasing. First, let us find out what is g of f of x. F of x is sin x plus cos x. So g of f of x is x, within the place of x, we have to substitute this. Basically, sin x plus cos x whole square minus 1. Okay. So sin x plus cos x whole square minus 1, which is nothing but sin square x plus cos square x plus 2 sin x cos x minus 1. Sin square x plus cos square x is anyway 1, and there is 1 minus 1 here. So this and this will get cancelled. We will be left with 2 sin x cos x. That is nothing but sin 2x. Right? Sin 2 theta is equal to 2 sin theta cos theta. Right? We have sin 2x. Sin 2x, sin x, what is the period? Period is 2 pi. Right? Sin x period is 2 pi. The violet graph, sin x, it will take 2 pi. 2 pi is roughly 6.2. 6.2 is right. Pi is 3.1. So 2 pi is 6.2. So this one, this violet graph, this is a period for sin x. Okay. When it is sin 2x, it is actually compressed by sin x compressed by factor of 2. That means if for one complete cycle it is taking 2 pi, it will take sin 2x will take it will do 2 cycles in 2 pi. That means it will take a pi for completing the cycle. Okay, that is 2x. That's why the period is actually pi. That means every pi it will complete a cycle. Within 2 pi, it will complete 2 cycles. Okay, so this is the sign for 2x. So the period is actually pi. Now, this function sin 2x has to be invertible. What does that mean? It has to be 1 1 first. Okay, it has to be 1 1. Only a 1 1 function can be inverted. Okay, that is for what reason? Because, so for example, if I have to invert a function, okay, what is inverse? Inverse means it is a reflection around y equal to x. Okay, let us take this line, and let's say this is a graph. The graph is when y equal to x square is on graph, which is this complete thing. Now, y equal to x square when x is greater than or equal to 0 is the right part of this. Okay, that is this part. Now, inverse of this is a reflection around this line. If I put a mirror here, then within the mirror you will see this one, right? You will see this one. So, this graph, the right part of it, the inverse of this is this one. This is x square. This is root x. This is when x is greater than or equal to 0. Okay. So now this inverse. So for example, if this point, the point is 1 1, the point 1 1 is there on both the ones. So this is the point 2 4, right? 2 4 in x square if x equal to 2, y equal to 4. Right here, the point will be 4 2. Okay. Here the point somewhere will be 3 9. Here the point will be 9 3. Okay. Just xy will be inverse. Here, if it is xy, the same will be reversed on this graph. Now, if you can clearly see, this is a reflection around y equal to x. If you include this part also, if you include left part also, what is the reflection? Reflection of this graph is this one, right? Reflection of this one is equal to this one. But if you include this one, if you include this part also as a graph, this is not a graph. Why? Because for the same x, we are getting two different y's, which is not possible, right? For a graph or for a function, one x can give one y only. If it is giving one x is giving two y's, it is not a function, right? So not a graph. That's why we cannot include this part. If you include this part, there is no inverse. If you take only this part, there is an inverse, that is this part. Or if you take only the left part, then you will get only the inverse as the bottom part. Okay, so that's why we cannot have. So what is the problem with this taking both of them? Because why we are getting two y's at the same x? Because if you take this, then you will have two x's for the same y. That means it is onto form. So that means it is not 1 1. It is not 1 1. if you have two x's, to this x and this x for the same y, then it is not 1 1. 1 1 means for each x there should be only one y. For each y there should be only one x. Because there are two here, here it is getting reverse and we are getting two y's for the same x, which is not possible. That's why for 1 1 it is mandatory that the graph is either continuously increasing like this or continuously decreasing like this. Anything can happen. Whenever there is a small blip, what that means, once you reflect, it will become something like this, and then you will have two y's for the same x. Okay, so a no function which can even which is not completely continuously increasing or completely continuously decreasing cannot have an inverse. If it has to have an inverse, it has to be either completely increasing, however small. It can just, the slope can be small, but it has to be either completely increasing or completely decreasing. It cannot happen that at some point it has taken a blip and again continued increasing. No, then it will fail this horizontal test. Okay, horizontal test. If it is failing means at two x's are giving the same y. That means two for the same x you will get two y's here, which is not possible. Okay, so now in our current diagram, this sine 2x to make it have an inverse, what we have to do, we have to pick the part where it is continuously increasing. Okay, we have to pick the part where it is continuously increasing. Okay, if it is a sine x curve, it will completely continuously increase from minus pi by 2 to pi by 2. Sine pi by 2 is 1, minus pi by 2 is minus 1. Now because the period is half now. What does that mean? It will sine 2x will continuously increase from minus pi by 4 to pi by 4. Everything becomes half. Right? The period become half. So the lowest point and highest point, they also are compressed by a factor of 2. So the domain in this case, if it is between minus pi by 5 to pi by 4, this function is continuously increasing. That is sine 2x, which is nothing but sine 2x is nothing but this one, g of f of x. Okay, so then we can do the inversion. Okay, what is the inversion? Inversion is just flipping this with respect to y equal to x. So for example, if the graph is something like this, then you flip it something like this. Okay, flipping with respect to y equal to x. Whatever is here, it is here like this, then it will become here. If it is like this, then it will become like this. Basically, if you put it on a piece of paper and fold the paper along this line, both will coincide. Right? That is the graphical representation of an inverse function. Draw the graph on a piece of paper, hold it on the line y equal to x, that is the line which is at 45 degrees. Then if you fold it, both should coincide. Or if you put a mirror here, then you will see the reflection like this. Okay? Right, guys. So that is how this g of f of x is invertible in the domain minus pi by 4 to pi by 4. Right, guys. Thank you.